what the risk is for our fungicides. The best site with the most amount of information is the Fungicide Resistance Action Committee's website. You can very easily find it. Here's the website for it. If you just Google search FRAC, you're going to turn it right up. And if you go over and click on publications, 2 pages later, you'll get to where the publication list is. And in that list is what's called a code list, and you can see the year associated with it. This list gets updated at least every year, so it's a very up-to-date list. So you can download that list. Here's information that's within it. It's a very long list of all the fungicides that are available globally, so it's a big, long list. The list now is organized not by the FRAC code number, and these numbers are assigned with each and every group of fungicides that comes along. So 4 refers to the 4th group that came along and was developed. Now they're organized by mode of action. So they're bringing together all the products, in this case, that are acting on nucleic acid synthesis. So you can get a lot of information about mode of action, target site for these products, as well as what the resistance risk is. So as you look down the common names, and these are all the active ingredients, you probably don't recognize most of these. Should recognize methanoxam and metalaxyl, and those are the products that have been registered, or the active ingredients that are in some of our fungicides that are registered here in the U.S. All of these others are products we do not have here. And what you'll see over in the comments is the information about risk. So metalaxyl and methanoxam, they have high risk. We've had a lot of cases of oomycete pathogens developing resistance. You'll also see some comments here about what the resistance mechanism is if we know. And here, while it's common, we've had resistance for a while, still don't know the mechanism of resistance in the oomycetes. And there are some groups where resistance is just not known. We don't have don't have that information yet. So good amount of information at this website and in this code list. If you continue down the list, the next group is the ones that are involved with mitosis and cell division. See some more fungicide names that you recognize if you know your active ingredient names: Benamil and sulfonate methyl. Ones where we know the resistance, so here's some information about it. It's a target site, so there's information about what the pathogen is. This is FRAC code 1. This is the very first group that was ever developed, so the first of our modern fungicides with single site mode of action. And my last presentation on Monday, I talked a little bit about negative cross resistance. And here's that case of where we have the negative cross resistance. And what it is this group of fungicides, because they're closely related, that when change in this group pathogen, it makes the other fungicide bind more easily. So where you get a negative cross resistance that's happening. So there's it's give you a feel for some of the information that's available at that FRAC code list. What it includes is active ingredients that are not available in the U.S. So what I did is I pulled together a list that has active ingredients that are registered for use on vegetable crops. Since that's my focus, a lot of these products are available for other crops as well, but mine is vegetables, so that's my focus. So the beginning of the group has the contact fungicides. A number of these are older products that we've had for a number of years. And then after the heavier line, we get down into products that have a lot of the medium to high risk of resistance developing. 60 products in this list and 39 active ingredients. That's a pretty long, extensive list. It obviously goes down below this page. But just to give you a feel for how many products we now have that have some degree of resistance risk to them. How are you going to get this risk? Well, you'll get it if you go to the Moodle website. I've got this posted there. So if you go to the page and get to the current web, that's where it's posted. Go and get that full list for yourself. Eventually, I'll get it up at the Vegetable MD Online website where I keep a lot of information. But at a point in time, if you want it, you got to go to the Moodle site. I've got some other information up there that you'll find possibly useful. The number one here is this resistance management guide. And then if you go further down the page, you'll find some articles that include some information about resistance management for those particular crops and diseases, and in particular the one on cucurbit powdery mildew. And that's what I've been working on the longest in my career here. In fact, that's how I started my career, was working on resistance to that pathogen. But take a look at the guide and what's there. If you click on that, you'll download this guide, many, many pages. And what it's got is a page for each of the crop groups. And it has the FRAC code for the different fungicides. So fungicide, the active ingredient, the FRAC code, then what the resistance is for the side, the fungicide. This all comes from the FRAC code. And also lists what is the potential for resistance to develop in the various pathogens that are causing these diseases. So I think it's got a good wealth of information, plus some resistance management guideline steps for you to consider.
Hey, I could just jump in for a sec. Are you still using the laser pointer?
I am.
Okay, because it is not visible anymore.
I guess then I'll just point with my finger and you will have no idea what I'm doing.
Okay.
That's weird. Do you think I should try another pointer?
Maybe another pointer.
Is that working?
Nope, that one either.
Okay, I have no pointers. I'll better describe everything. Resistance. This comes from the talk that I gave on Monday, just regarding what you want to do with the pesticides that you're using. We talk about alternating amongst products that have risk for resistance to develop. There's products in different classes. You could have a simple alternation or a block alternation. And then the next step is to also be tank mixing these with those low-risk contact broad-spectrum fungicides, which are on the top of that pesticide list that's at the Moodle site. Basic steps for managing resistance. And I've given you a couple places where you can find that information. You can also find it on the label of your fungicides. So here's an example. Here's the Quadris label. The arrow that I've already got here is showing you where that information is on the label. So it's saying do not apply more than one application of Quadris or their Group 11 fungicide before alternating. So it's a situation where with a product where you cannot use a block alternation. You cannot apply Group 11 fungicides twice in a row. Realize that the information that you find on this part of the label, it'll be other remarks or use directions will be titled at the top of that column. But what it is on the label, along with the crop and the target diseases, that is part of the legal part of the label. So this has got to be followed. This is not a suggestion. This is a requirement. Remember, the label is a legal document. So growers have to follow that. No block alternations with Quadris. So the time on the label, I see up to 2 consecutive applications being allowed if there is a restriction. Here's a label for Rainman, and you will see that it allows, under resistance management here under instructions, it says do not apply more than 6 sprays, alternate, and then that first arrow is saying make no more than 3 consecutive applications. So you could have a block of 3, but realize when you apply something like Ranman 3 times in a row, if you do the consecutive, typically there'll be a statement afterwards next to that second arrow where it says it's got to be followed by at least 3 applications of another fungicide or fungicides with different modes of action. So block carries over to the next fungicides that are being used. You can't apply Ranman 3 times in a row, switch to Quadris, and go back to Ranman, for instance. You fit 3 more applications. And remember, that is a legal part of the label. It has to be followed. Sometimes you'll have a product where you'll see some information on the web, or you'll hear, for instance, as I'm going to be giving in my talk, that there's some resistance with a product. You'll go and look at the label and you won't see anything. And that's the case here with this part of the label for Rally, for cucurbits. Powdery mildew is the only disease that's on this label, only thing it's effective for, when documenting some of the single site action, narrow spectrumness of some of these products. And you can read all the use directions and restrictions here. There is nothing in the section of the label for cucurbits that says anything about resistance management, although we've had some issues with resistance to this group dating way back. If you go further down in the label and get to the strawberry area of the label, you're going to find that there is a statement that says to comply with the resistance management recommendations in the general use section. So that's the other part of the label to look for resistance management guidelines, is that general area of the label, which is usually which is in the front part of the label. So 2 places in a label you need to look to some resistance management. And if we do this with the Rally label up near the top, you're going to find a whole section on resistance management. Information here, underlined in red. It says consider the following practices. So here it is a suggestion, but in the other part of the label, it is a legal requirement to follow it. So number of practices here that go over some of the things that I've already talked about, for instance, using an integrated pest management program. A statement you'll see frequently is contacting your extension specialist for up-to-date information. I was glad to see that. And then the last item here is if you suspect resistance, to report it. That's very important. Realize that if a company does get a report for resistance, they need to follow that through, and if they confirm resistance, that's something they have to report to EPA. The Quadris label, again, up in its general section on resistance management, I've underlined a couple things I thought were important to point out. Freely, this statement of development cannot be predicted, so realizing you need to have a resistance management program because we don't know when resistance is going to develop until it does. There's a statement to contact extension specialists, which good thing you guys are all learning about resistance management since these are all on these labels. Once again, general section, so it's saying strategies may include, so they're general resistance management section. Some of our fungicides that are on the market, particularly some of the ones that are coming out more recently, are combination products. And a number of these are combinations for the goal of managing resistance. And that's the case with this new product, Zampro. It has 2 FRAC code, it has 2 active ingredients on the line here, and they're in FRAC code 40 and 45. So 2 different chemistries, but both of the active ingredients do target oomycete pathogens. So we're looking at a product that's got 2 different ingredients, both having some resistance risk, that are being combined together to help with resistance management. So we've been talking more about alternating, but your other approach for resistance management would be to combine 2 different active ingredients together. One of the active ingredients, this dimethomorph, is the active ingredient that is in Forum. So this is kind of an improved Forum, so to speak. The other types of products that I see is combined with a broad spectrum type of a fungicide. So the second one in this list here of the new Orontis is called Orontis Opti, and there's the active ingredient, the Orontis part of it combined with what's the active ingredient that's in Bravo, which is chlorothalonil. Brand new product, not quite on the market yet, but we'll see it darn soon. The other 2 products that are coming out with Orontis are Ridamil Gold is one ingredient, second ingredient, or Revis is the second ingredient, and both of those are products that are targeting the oomycete pathogen. So new fungicide that's going to be out very soon. It's only going to come out as combination with other active ingredients, and most of the time it's in combination with other targeted fungicides that are targeted for the same group of pathogens, the oomycetes. Sometimes what we see is fungicides with a combination of products, and the whole goal is to increase the product activity. So it's not for resistance management, it is so the product is going to be active for many more pathogens that are out there. And a very good example is Revis and Revis Top. And I decided I ought to have one fruit example in here, so I took the section off of the label. So if you look at Revis and look on the left side of the screen, that is from the Revis label for grapes, and the only disease you'll see there is downy mildew. And if you look over at the right side of the page, that's the label for Revis. That's the section from the Revis top label, and you'll see many more diseases that are listed here that are some activity with this product, with Revis top. So if you've got grapes, you've got a couple diseases occurring, then you want to be using Revis top. If downy mildew is the only disease of concern and the other diseases are not causing a concern in a particular planting of grapes, then Revis is the product to be using. So you're not putting selection pressure on any diseases, pathogens that are out there at a low level that's just not of concern in that particular crop. So those are things to be keeping in mind. Another thing I wanted to point out and to realize is that when we're looking at resistance management, be it in pathogens or insects, weeds, we're looking at a population. So each of those spots on this leaf could be a genetically different individual. And some of those spots could be the same, since it is a asexually producing pathogen. So that's something to keep in mind. You've got a population out there. The other thing to realize is that our fungicides, even our products that we've got, aren't going to clean up and get rid of those spots that are there. You know, insecticide can kill some of our insects, but our pathogens, once they're established, you're not going to slow it down. So if this is what leaves generally looked like in a crop before the first application had been applied for powdery mildew, I say forget using those targeted fungicides. You're not going to slow this disease down. You're putting way too much selection pressure on that population. So those are things to keep in mind. That's a population out there, and those spots ain't going away with any fungicide that we've got available today. We do that kind of curative activity. The other thing to realize is if you were to look very closely at just a section of one of those powdery mildew colonies, there are chains and chains of spores. Each one of those spores has the potential to go off and cause a new infection. So there's just tremendous explosive potential with some of our pathogens that produce a lot of spores, like the powdery mildew one. You'll see the pathogen grows on the leaf surface, and then down below you're seeing down in the cells what are called these hostorium, the hostorium that is inside of the leaves. That's once the pathogen's inside of the leaf, you're just not going to stop it with fungicides. So each has the potential to land on the leaf and to germinate, and it's during this process when it's germinating, producing the penetration peg, and before it's gotten into the leaf and just a little bit into the leaf, which is where our fungicides are effective. Some of them are only going to have a role during the germination process. Some of the very early stages of infection, we can get a little bit of curative activity, but really the focus is on stopping the spore germination of infection. So that's what we're targeting. We really want to have those fungicides out there for the pathogen-producing spores, because it's just going to continue to produce a ton of spores. And the other thing to realize is from deposit of the spore on the leaf until you've got a colony like this is about a week. So very quick turnover, and that's why we can get such explosion of this disease and why we can shift the population to being resistant very quickly. The pathogen just multiplies very fast, and a number of our pathogens are that way. They'll go from spore, start to germinate, to a lesion producing spores in about a week. An example of cucurbit powdery mildew, I think it's a good example to kind of understand resistance management, and it's the one I've been working on for almost forever. Our management tools for cucurbit powdery mildew are resistant varieties and fungicides. That's it. They're easily wind-dispersed spores. We can't avoid this pathogen. We recommend an integrated program using both of these tools, both the resistant varieties and fungicides, because the pathogen's got the potential to adapt to both of them, not just to developing resistance to fungicides. As you can see from looking at this leaf, on the underside, the powdery mildew colonies are bigger, they're fluffier, there's more spores being produced. The pigeon's obviously a lot happier on the underside of the leaf than on the top side. And that's why we really need to have these mobile, single-site mode of action fungicides that can move through the leaf, get to the underside, and control the pathogen there. But those are the products that are prone to resistance. Got to be managing resistance to get effective control. Now, if you were to spray leaves of cucurbits with just a broad spectrum fungicide, a contact fungicide such as Bravo, which is what this leaf was sprayed with, you can see you've got control on the top side of the leaf and horrible control on the lower side of the leaf. And what's going to happen is that leaf is going to turn yellow and die prematurely, and that's going to affect yield quality for sure and possibly quantity of yield. Got to manage powdery mildew, and we've got to manage it with our mobile fungicides that are at risk for resistance. Here's a history of resistance development. This is just in the U.S. The first product that we had that was a mobile product was Benlate. So it's in our FRAC code 1. That's our very first group of fungicides that we had that had activity. Notice that resistance was detected in 1967. The product was registered in 1972. That is not a typo. There was some work being done just kind of looking at isolates. This is actually work that was done at Cornell in Geneva back in the late 1960s, and they picked up a couple strains that were resistant. This was the beginning of having these products with this site-specific activity. Didn't know anything about resistance. We really didn't react to it. Didn't thought that was some kind of interesting thing, but not going to necessarily be an issue. Product was registered in 1972, and it wasn't there not long after that failure started to be detected in university trials and then in commercial fields. So resistance certainly was an issue. I was around back in that time period. I was pretty young, but so to see this resistance having started during my on the face of the earth, to me that means it's a very recent thing. And a lot of changes have happened in this time period. I think is valuable to keep in mind. That really wasn't that long ago that our first product was all. The next fungicide that we had with mobile and targeted activity for cucurbit powdery mildew was Balaton in FRAC code 3. These are the demethylation inhibitor fungicides. One was registered in 1984, so a number of years after Benlate had appeared on the market, and it was a matter of a dozen years. Growers were starting to have problems with control. That's when I started working at Cornell and looking into why were we seeing some control failures with this product. The next ad was Quadris. Years before we had another product available to use. This is in our FRAC code 11 group. I think what I'll be seeing here as we're going down this list is there's a lot of time that we've got one product, nothing to rotate with, no product to be using in a resistance management program. I think that was a lot of the challenges in our early years. Resistance to the FRAC code 11 group appeared pretty quick, so that's 3 years from registration to resistance being detected. It's another reason these pathogens just continue to produce resistant strains to evolve pretty darn fast. The product that came along was Pristine, FRAC code 7, registered in 2003. 5 years later, we've got resistance. So track records just continuing to go along with the pathogen adapting to the products as they come out. So here today, we got several products now available. Quintec, Torino, Vivando just came along. No resistance yet to these groups. So we finally are at a point where we've got multiple chemistries that we can alternate among our resistance management program. Now, this is from Quadris, and if you look at the bottommost arrow in the center, it's pointing to powdery mildew. It's still on the label. I just showed you that we've had resistance for a number of years to that. And actually, just before we discovered resistance to the powdery mildew pathogen, We'd found resistance in the gummy stem blight pathogen. And back in about 2004, we realized we had resistance to the downy mildew pathogen. So we've had resistance for a number of years to these groups. They're probably widespread in the U.S., but there's a lot of monitoring work that's going on. If you look under remarks, where the other red arrow is, you'll see mention in this that there are any problems with resistance to any particular group. In fact, it starts right out with for downy powdery mildew, preventive applications, blah, blah, blah. I would not recommend this fungicide for those diseases because of resistance issues. That's another take-home message. You're not going to find much for information about resistance occurrence on labels. You'll find a lot how to manage it, and this reflects the fact that we're not out doing extensive monitoring to be able to say that these fungicides have widespread resistance in the U.S. I suspect they do in this particular case, but that information is not out there. So don't turn to the label to know what resistance is occurring. Turn to the web, look at the FRAC code list, look at resistance articles that are coming out by people such as myself. That's where you'll get that information. The cucurbit powdery mildew pathogen is a good one to go back to, talking about qualitative and quantitative resistance. There are two major types. To kind of keep the terms, understand the terms, look at qualitative. That's got the word quality related to it. So it's, it's quality. There's no numbers there. It's either sensitive or completely resistant. You got one gene involved. It's a quality thing, qualitative. So when you get resistance where it's one gene involved, pathogen becomes completely resistant, you're going to get complete loss of control. And that's what happened with benlate and the QOI fungicides like Quadris. This quantitative resistance, quantity, we've got several genes involved. Because there's several genes involved and the pathogen with a mutation that occurs, it's gaining a little bit more resistance, it's becoming a little less sensitive. You're going to have a range in sensitivity in the pathogen. So as the pathogen continues to evolve, you're going to see a gradual loss of control. Now, what can happen is if you use the highest rate of a fungicide, you may be able to get control back, or if you use a more active fungicide in that chemical group, you can maintain control. You can get control with this group. Whereas with the QI fungicides, it doesn't seem to matter. You got resistance to all of them. None of them are working. And this the example here is the DMI, the code 3 fungicides, and this has been true for cucurbit powdery mildew pathogen, and also some of our other pathogens have exhibited quantitative resistance to the DMI fungicides. So an example of a mode of resistance, looking at the QOI type fungicides, is a target site mutation. Most pathogens who have developed resistance have developed one mutation where you get the alanine amino acid has substituted for the glycine in one particular protein sequence. So if you look at the two diagrams here, you'll see a I wish I had my pointer to show you, a very slight difference of where one amino acid is changed. And that is enough to prevent fungicide from binding to that protein sequence. Just that one amino acid change, and now the fungus individual, the biotype is completely resistant. The fungus can't bind. You've got resistance. This is the most common target site mutation to the QOI type fungicides. We've had convergent evolution here where a number of pathogens have developed this mutation. There's a second mutation that's listed here. That's been a little less common, but that's another one that happens. So just to give you a feel for our modes of resistance and what happens when pathogens become resistant. Feel for what would happen to the whole population when you've got qualitative versus quantitative resistance. So if we start with qualitative, which means that the pathogen's either sensitive here in yellow or it's resistant, the couple spores that are red. So this is our populations of spores that are kind of out in the field when the fungicide was applied. And after it's been applied, no matter what rate you use, low or high, the only spores that are going to be left are the resistant ones and a couple escapes. So a couple that land low down in the canopy where the spray residue didn't get, or other spot where, the spray just, you did perfect coverage. That's going to happen. You'll have a couple of escapes out there, but pretty much what you've done with that one application with qualitative resistance, selected for the resistant ones. And those spores are going to germinate and penetrate, and within a week they're going to be producing all these spores, and so very quickly the population can shift to where you've got all resistant ones if that fungicide is continually used. And there's a few sensitive ones in there from escapes, but not many. With quantitative resistance, the pathogen population is exhibiting different sensitivities to the fungicide. You've got different colors to represent different levels of the fungicide that they can tolerate. A lot of yellows, sensitive ones that are out there. So that's the population when the fungicide was applied. And you use a low rate. You have some immediately sensitive ones that are going to survive, plus a couple escapes. But those they're different levels of sensitivity. If a low rate is applied, you've got a couple different sensitivities that are able to survive. Whereas if you use high rate, all that's going to survive is going to be escape, unless you've got a few already completely resistant strains. Late on in development resistance, they're not there yet. Kind of your difference in your qualitative and your quantitative resistance. So how do we determine if resistant biotypes are present? Scientists, what we'll do is we'll collect isolates from infected plants. We'll test them on amended media. It's a culturable pathogen that will grow in artificial media and a petri dish. Yes.
Mrs. Hillary.
Yeah.
Just the audio was just cutting out, and I think you were making you were kind of tying up your points in the qualitative, so I didn't know if you could just go back and do that because we're occasionally losing the audio.
Ooh. Is this better? I just turned it up.
It has to depend on you. I think it's just what's happening with the WebEx, but if you just didn't mind saying your conclusionary statement.
Yeah, it hasn't been too bad, Meg, but we've had one or two times when it would be good for you to repeat.
Oh, I'm sorry.
Oh, that's okay. Just wanted to let you know.
So, conclusion back to the slide is just to show that we use a high rate. Only pathogen spores that are going to remain that can survive are those that have escaped the spray. Whereas if you've used a low rate, then you've got some strains that can tolerate that low rate and they will survive. You'll always have a couple escapes. That's what that's meant to be. So now these that have survived, they're going to survive another generation. And if you continue to have selection pressure, there may be at some point in time another mutation that occurs and the pathogen becomes even less sensitive, and you're allowing it to survive and go through that potential to have another mutation. Yes.
Oh, Meg, it did it again at the exact same place.
Uh-oh.
So I don't know what it is. It doesn't like your final point, and it's shutting out. But
and I think this is a pretty important point, and that's the reason I jumped in. So I mind trying one more time. Maybe the third time will be a charm.
And you think I can remember what I was saying?
Yeah.
All right, so with quantitative resistance, when you've used a high rate, it's affected all of the biotypes in the pathogen population that have intermediate levels of sensitivity. So the only spores that are going to survive out there are the ones that have escaped being sprayed with a pesticide. And if you've used a lower rate, if I can get it to go back, you've some strains of the pathogen out there that can tolerate that low rate in the population, and they're going to survive and continue to multiply, and that gives them chance for additional mutation to occur because they're surviving and continuing in the population. That all works? Still hearing me out there? Testing the pathogen isolates that we've collected, pathogens that can be cultured, and then we can test them on amended media. And then some pathogens, such as the cucurbit powdery mildew pathogen that I work with, we have to test it on plant tissue. The other approach that can be taken is if we know the gene, such as we know what the gene is for resistance to the QOI fungicides. Once you know that gene, if you can develop a molecular test, you can just test the pathogen directly for presence of that gene. And you can imagine that we test a lot of isolates doing these particular practices if we've got to test them on amended media or plant tissue. So another limitation to the testing procedure. So this is a procedure that I use. We maintain the isolates on plant tissue on water auger and pea dishes. It's an obligate pathogen. Has to be living plant tissue. I can maintain about 6 isolates at a time. It's time-consuming to keep them going. What we do, we spray cotyledon leaf tissue, these little seedlings, cut out leaf discs, put them in petri dishes. So you can see I can have 3 fungicide concentrations at a time in a test, plus a non-treated control. So not a lot of testing that can be done at any one particular point in time. Very laborious to go through this. But it does give us information about each individual and what its sensitivity is. The work that I was doing with the DMI fungicides in the early 1990s is when I started doing work looking at the sensitivity, doing that test. At that point in time, we had control failures with the first DMI fungicide, Balaton. The next fungicide in development was Nova. We now know it as Rally. It was very effective in university trials, so that's showing you a new DMI fungicide. It's inherently more active. It's effective, whereas our first DMI fungicide, less active, not working more at all. And at that point in time, most of the isolates that I was testing were able to tolerate at most 2 parts per million of the active ingredient in Nova. By the late 1990s, most of the isolates that I was testing were able to tolerate 20 parts per million. So now we've seen a shift in the pathogen population over a period of less than 10 years, and it is tenfold its insensitivity to myclobutanil. In 2000, Nova was registered. As I commented, it's recently been renamed Rally. At that point in time, when it first came on the market, the low-labeled rate was ineffective. It was effective back in the early 1990s when we were testing it, but the pathogen population had continued to evolve with the use of Balaton, continued to be shifted, and now we've got strains that aren't sold at the low-labeled rate. And that's part of why we recommend a high-labeled rate, is to control those less sensitive strains and to give you control if resistance has started to develop. Now, since 2000, I've detected some isolates that can tolerate up to 80 parts per million myclobutanil. That's not that big of a shift. If we'd done another 10-fold shift, we'd be up to 200 parts per million, but that hasn't happened. So we're still getting a little bit of shifts with the pathogen, but not as much as we had back years past. New DMI fungicides have come on the market. Control's been variable, but often good. These have remained tools we can use. Here's a list of the DMI fungicides that are presently out. Plain is a brand new one that's out, and Procure, these are the most effective ones, and then going down the list are less effective active ingredients. So all FRAC code 3, but they do vary in their inherent ability to control cucurbit powdery mildew. The assay that I have done is the seedling bioassay. I do this in commercial fields. These seedlings that have been treated with different concentrations of fungicides, I put them out for a day in a commercial crop where there's powdery mildew, bring them back to the greenhouse for 7 to 10 days until powdery mildew develops, and then rate the amount of powdery mildew that's on the leaves. And I think, to me, one of the things that's interesting to look at is that non-treated control and just how much powdery mildew is there. Those plants were out in the field for a day. It just shows you the amount of inoculum that can be out there, the amount of wind-dispersed spores. Now, there's powdery mildew on that leaf that was treated with flint, and then below it, the leaf that was treated with Topsin M, showing resistance to the FRAC code 1 and the FRAC code 11 groups. I continually find resistance to those groups. I continue to do either this bioassay or more commonly testing isolates every year, and I find a very high level of resistance resistance to those two chemical groups in every year. The one that's very interesting is the FRAC code 1, because that's not a fungicide we are using very much anymore, but we're maintaining the resistance in the pathogen population. Not a fitness cost to having it. There's no selection to make it go away, so it's maintained there. Next, you can see some growth on the leaves that are treated with 80 parts per million of the two DM fungicides that I tested that year. And then the next ones are Boscla, that's the active ingredient in Pristine, and then a Quintec. And you can see that I've got exquisite control, so no resistance to that level of those two fungicides. Excellent control with those fungicides, and that's back in 2008. Another sort of leaves from another assay just to show you the range and sensitivity with the DMI fungicides. So you can see at the low rates of Nova, myclobutanil, the 20 and 40 parts per million myclobutanil looks about the same as the control. 80, not much better. You get up to 100, there's a little bit less. Once you're up to 120 parts per million, there's no isolates that can tolerate that concentration. No bites out in the field. So we're showing you that quantitative resistance that's occurring. Sorry, this slide looks like it's shifted over a little bit. Those numbers should be underneath the Procure. So a couple of things I wanted to point out here. This is the concentration that would be in the spray tank for Nova and for Procure. So first of all, Nova is 40% myclobutanil. Procure is 50% of triflumazole. So Procure's got a higher amount of the active ingredient in it. It's also labeled at a higher rate. So if you look at the numbers in this table, depending on what gallonage per acre in the spray tank, showing you what the concentration would be in that spray tank. And you can see with Procure, you've got a higher amount of active ingredient. Sometimes why Procure is recommended over Nova. And the other thing you'll notice is you're getting up to your higher gallonage, you're getting into numbers that are similar to what I was just showing you that the pathogen was growing on in leaves from those bioassays. In order to compare what's happening with the bioassays and what's out in the field, because certainly then the next step is coverage with your leaves. So the lower the gallonage, yes, you've got higher concentration of fungicide, but you're not going to get as good coverage on the leaves. But it is showing you that some of the concentrations I'm looking at that the isolate that some of these biotypes can tolerate is similar to what is in the spray tank. Here's a list of the fungicides that are labeled for powdery mildew in the U.S. And some of them you'll see I've crossed off because there's such a high level of resistance, I don't expect them to work. And those two have the qualitative type of resistance, so we don't have intermediate levels of insensitivity. So the DMI fungicides, we've got quite a few. Proline is the one that has the most inherent activity. With the FRAC code 7 fungicides, the SDHIs, presently Fontellus is my choice of the products that are out there. Boscalid is in Pristine, so you're using Pristine. You also are putting out a strobilurin fungicide, and we already know that those aren't working. So I don't like to see selection pressure going out for a group that we've already got a lot of resistance to. The Luna fungicides are actually the absolute best use of the SDHIs, but at this point they're only labeled for use on watermelons. And then we've got Quintec, Torino, and Vondo, 3 different groups to be using in the program, so a lot of things to alternate with. So I'd recommend to a grower to alternate amongst all of this chemistry. And then we've got to be aware of our restrictions. So this slide, what I've got is restrictions of what applications you can use on the label. So Vivando, you can only put out 3 total applications of it to a crop, and only 2 of those can be consecutive. Quintec, 2 consecutive, 4 total. You need to be alternating amongst the products anyway to follow the label and to have a legal spray program out there. Torino is restricted to only 2 applications for resistance management, and then with the last 2 groups, I'd only recommend 1 application of those. A grower could put out more, but I only recommend 1. So hopefully with a kind of alternation amongst all these, a grower can get decent control. And then the last step is to tank mix these with a protectant fungicide. And the reason to use a protectant protectant such as chlorothalonil is because it's going to control any resistant strains that it happens to be deposited on, which is going to be predominantly the upper leaf surface. Hard to get good coverage on the lower side. The other thing that I do every year, and a couple of my colleagues at other universities do, is we will test some of these products, have a resistance risk all by themselves in a spray program, just to see how well they're working, and that will really give us a feel for when resistance has developed to some of these products. So here's some of my results from the years. Now notice I'm looking at control of powdery mildew on the lower leaf surface because that's where it develops best. Area under disease progress curve, the variable I'm looking at is a measure of powdery mildew over the course of the whole season. So looking at control, that means the bigger the number, the better, and the white values mean that it's not significantly different from the non-treated control. First two lines are showing the DI fungicide Procure applied at a intermediate rate, which is the 6 ounces, or the highest labeled rate, which is 8 ounces. And you can see in 2009 and 2010, I got control highest labeled rate, but not with that intermediate, showing when you got quantitative resistance, it really does make a difference to use the highest labeled rate. The next line is pristine, and you'll see that has some variable results over the years. Past few years, it has not worked. Yeah, a little bit less powdery mildew on the plots than I did in the non-treated, but not significantly different from the non-treated. The one year that I also looked at Fontellus, which is the other FRAC code 7 fungicide, you'll see no significant difference between those two. Neither were effective, and that's in 2012. If you look at 2011, you'll see all of those numbers are white. Even Quintec, which gave excellent control in all the other years, and this particular year, the spray program was started a little bit late. I usually start when we first find powdery mildew and really hunt to find it, and that year there was a little bit more out there than I would have liked to have seen when we started the sprays. Not quite as bad as that leaf I showed you earlier in the talk, but that documents that if a spray program is started a little bit late, it is very impossible to catch up and get decent control. So a very important thing to keep in mind. Now, if we continue along, in more recent years, 2013 to 2014, you'll see I've got excellent control with Procure and pretty good control as well with Pristine. And that's showing you the year-to-year fluctuations that can happen. Pathogen population is changing from year to year, so sometimes we have issues with control and sometimes we don't. But in Quintec, I've gotten excellent control most years, dropped off that 1 year because of poor timing, but it's maintained consistent control. And the last line is to realize that I've got excellent control with a program where I'm alternating amongst these products, even years where Procure or Pristine didn't do that well. So that's showing you that a fungicide program where you've got products in there that are standing up, i.e. Quintec, it can mask that you've got resistance issues to other products. Here's some more data. This is from 2006, just also documenting the same thing. Procure not working all that well. Quintec working really well. Pristine also that year working really well. And where Procure is alternated with either Quintec or Pristine, I've got fairly good control. Important things to keep in mind. Looks like these pages don't want to display. I'm not sure what happened there or what was on those pages, but we have minutes, I hope, here. So let's get back to some of those slides. I'm realizing I'm a little bit behind. Well, here with the FRAC codes, the FRAC code 7, that's the only problem, not being able to see my audience. I don't know where we're at. With the FRAC code 7 fungicides, as I mentioned, we've got a couple new ones that have come on the market. So one question was, do we have cross-resistance? I know I've got isolates that are fully resistant to boscalid. We know we've got some issues with resistance to that fungicide. Well, how are these new ones? And I did the same thing of testing using that procedure that I talked about earlier. And if I take an isolate that is sensitive to boscalid, and I tested against these other SI fungicides, it is sensitive. So isolate that's sensitive to boscalid is sensitive to these other chemistries. I also have control discs in a trial. Those were from non-treated plants, so I had that measured to show that the assay is working and the fungus is alive and well otherwise. Now, if I take a boscalid-resistant isolate, so one that's resistant to that pristine fungicide, it is also resistant to two of the SDHIs, but not to the fluopyram one, showing that we've got cross-resistance to two of these, but not to the third one of these groups. So cross-resistance to the top three, but not the last one. And go back to the FRAC code list, you'll see that fluopyram, that's that top red-lined names, you'll see its chemical group is different from the other ones, which are different types of carboxamides. So while they're all SDHI fungicides, they're all in that same group, there are also subgroups, subchemical groups. And so sometimes you won't have cross-resistance amongst everybody who's in different chemical groups. That's something very, very important to keep in mind. And this just structure shows you what these different fungicides look like, the active ingredient. So if you put them all together, this one structure here on the top where you've got the four structures superimposed, you can see that fluopyram in yellow is a little bit different from the other ones. And if you were to look at a diagram of a leaf and where it's binding, you'll see it binds a little bit differently than the other ones. They think it has a tighter binding, and that's why that one is still effective and isn't showing the cross-resistance. So last couple of minutes here, I just want to cover a couple other pathogens just to go over resistance issues with those. So with the cucurbit downy mildew pathogen, here's the fungicides that we have registered in the U.S. Resistance seems to be pretty widespread to Ridamil and the quadris, so the FRAC4 and FRAC11 fungicides. That was detected back in 2004 when the pathogen underwent a big change in the U.S. Had recommending those fungicides since then. In recent years, we're starting to pick up and detect issues with control with Presidio and Prevacure Flex. We believe it's a resistance issue, and that's being looked at now. But you see, we do have a long list of fungicides, so similar to cucurbit powdery mildew. We do have quite a number of fungicides available to use. We've had these for a number of years, which does raise the question of, okay, we had good potentials for alternating. Do we have resistance despite the fact we had the tools for alternating? Or does it mean, yes, we had the tools and people weren't alternating, and that's why we've got resistance? Presidio and Prevacure Flex were being recommended as being some of the better products, so that is possible as to what was happening. $1 million question. Now, some of those fungicides, if you look at this, the list had for cucurbit downy mildew. I've maintained that list and pulled and changed a few things, going to Phytophthora blight affecting cucurbits and peppers. See some of the same fungicides because this is another oomycete. We have resistance in FRAC code 4 group, but that product is still giving us some control where we don't have resistance. And then Ranman is the other one where we had some resistance detected, and it's only in the southeastern U.S. at this point. So not the resistance issues with this particular pathogen that we have with others. And this is a soil-borne pathogen. And here's just a list of what's considered to be characteristics of a pathogen that will make it most prone to developing resistance. Top of the list, reproduce asexually every season. Powdery mildews, downy mildews, several cycles. Certainly that's what's going on. The next is reproduce sexually. A number of these pathogens don't. So while that's been considered something that would make a pathogen more prone to developing resistance, some of the pathogens that we've had the most problems with don't reproduce sexually, or it's not an important part of their cycle. Reproducing sexually is certainly a way to combine different resistance genes, and that's why that's thought to be an important characteristic that would lead to resistance developing. And then the last is dispersing well in air or water, and that's just because you're going to end up with the resistant strains getting widely dispersed. And certainly our powdery mildews and cucurbit powdery mildews, and also late blight pathogen are going to move around a lot. Now, this is an interesting one because same long list of fungicides. Resistance did develop to the FRAC4 group, but we've since had a shift back to strains that are sensitive to it. So here's a pathogen we would have predicted as being high risk of developing resistance, and it certainly did. It was one of the first to overcome the FRAC4 group, but we haven't seen issues with resistance since. This one does tend to exist more clonally, less variation in the population. So the last slide I wanted to end with was just kind of some of the key points I've been trying to make today and also a little bit Monday, is just realizing that most of our modern fungicides have some risk of resistance developing, so fungicide resistance management has just got to be in our fungicide programs, our control programs for these diseases. Management goal is delaying resistance, use an integrated program. Recognize that our fungicide labels have some legally required practices for managing resistance on them, and they have no information on resistance occurrence. Not the place to look for that info. We've got fungicides that have been developed with multiple active ingredients. They're being developed either to compel resistance management by combining two different active ingredients that are targeting the same pathogen, or they've got ingredients that are targeting different pathogen groups to increase the product activity. And you can't tell that just by looking at the label. You've either got to look at multiple labels to try and figure out what they're doing, or search the internet to get more information about what these different ingredients are doing. Realizing that within a chemical class, fungicides can differ in inherent activity and labeled dose, as I talked about with the DNI fungicides. Realize that we have limited knowledge about resistance until it develops, and we're doing limited monitoring work with these different pathogens. So there's just not a lot of information, unfortunately, about resistance and its occurrence. Realize that it's difficult to detect resistance in a production field. Partly that's because we've got a lot of products now that are being used. It's become more difficult to detect. But if you think you have a case of resistance, it's really important to report it. We report it to someone like myself, another extension person, or directly to the company. And reporting promptly is very important so that we can figure out if indeed it's resistance. That's what I wanted to cover today, and probably we've got a bunch of questions. I haven't been paying any attention.
One question that I could see, Meg, and let me find it again. It was early on. Question, this site FRAC is excellent and up to date. However, the NA FRAC site, which is specific to North America, has not been updated since 2003. And the question was wondering, which recommendations do you follow, as they do differ slightly, FRAC or FRAC?
As been pointing out, the North American site has not been updated as much. The FRAC site is a global site, so you're going to have global information, which I think is very helpful. Often fungicides get registered elsewhere in the world before they're registered here, and it's helpful to know that when resistance is developed elsewhere.
Okay. Folks could, if you have a question that you just aren't really a great typist, you could unmute yourself. I think you can do that and just ask it if you'd like to do that. I'm not seeing anybody else want to type something in?
John Hertz, I think, just put up a chat. Or J. Rob.
Do you see the question about lower levels of control, suppression of disease? Not totally he's asking about.
Specific rate.
Okay, sure. Meg, do you understand? I'm not really sure what that question is asking.
Can you often just verbally ask the question?
Maybe I can do it for you. I can unmute you if you want to try to go ahead and test your audio there. Oh, I don't hear.
Okay.
We're from Dave Trinka.
They're only providing suppression. I think in that case, it's monitoring what's happening. You know, if you're using a fungicide that's got some resistance risk and it's not giving adequate control, and you keep using the product, you are putting more selection pressure on the population. I wouldn't keep using the product. If you're looking at a product that just inherently has a low level of control, maybe some of our softer chemistry, and you don't have a resistance risk, then I wouldn't be wrong about not continuing to use the product. Then it comes down to understanding what the nature of the product is. Using something a biological kind of control and it's only giving you marginal, I wouldn't worry as much about the level of control. We had better tank mix or alternation was another question. That's $1 million question. You have resistant strains in a population to really look at what's the best way to control. The recommendation has been to alternate, and part of the recommendation has been to alternate just because of the cost of some of these products. You start tank mixing 2 different products together, you're now getting up into the $3+ per acre to apply it. Is it really worth it? And as I said, until we've got resistance, theoretically, if you're going out with multiple modes of action, you're putting a lot of selection pressure on the pathogen that can't overcome. It's almost like if you're going out with 2 modes of action that have high risk for resistance. It's kind of like going out with a multi-site fungicide. You've got that the pathogen's got to overcome. Theoretically, it should be harder, but we're turning around and putting these fungi that have multiple resistances out there. So it's happening. With post-action period spray, comes down to whether you're looking at a product that's got some curative activity. I hadn't talked about was length of period that some of these products are effective, and they do vary, and that's something to keep in mind when it comes to your alternation programs. So doing a post-infection spray with something that's got some curative activity, selection pressure, but if you've gotten it very early on and it is effective in that mode, that would be okay.
So about 3 or 4 other questions that went to me.
Okay.
I don't know if you get anything directly to you or not, but a question about Captivate, Switch, Pristine. Are the AIs in these combination products combined to broaden disease control or to manage resistance?
Now you're asking about products that aren't, let's see, I'd have to pull up the active ingredient list. The Captivate, that Captan, does anybody remember which? That's not a, well, that one that's registered on vegetables, so I'm not remembering off the top of my head.
Real quick, I don't know either. I have to look it up.
And this, I believe, is to expand the label, but that's one I would have to look at a little more closely to be sure. Some of them it's hard unless you can pull out labels that have each component separately. Then you know for sure. You could do with Switch and Vanguard. Same active ingredient. Vanguard has just the one, the Cipronel.
Sorry, of course, I'm just taking this forever. Well, I'll give you another question. I'm still looking up Captivate. Which fungicides are we seeing resistance to? Oh, you might not know this. In Botrytis on blueberry, is it different in New Jersey versus Florida versus Washington State? And I really hoped Kerry Cox could join us, but he's at another big meeting. If he would have been able to answer this right.
Botrytis is botrytis. Botrytis has developed resistance to a number of fungicides. Don't know different active ingredients. I right off the top of my head because botrytis is not a disease I've been dealing with. But that you're looking at a broad spectrum botrytis. It developed resistance. Unless people are out monitoring it, is hard to know.
So, other question: Captivate is Captan and Fenhexamid, and that's a M4 and 17 frac code.
Spectrum.
Okay.
So that you're looking at it as similar to a number of fungicides where you've got chlorothalonil in the fungicide.
Okay, so broadening disease control.
Broadening, but having a fungicide in the tank that has low resistance risk.
Okay. Then the question, is the late blight case an example of reversing the course of resistance development?
To be, it's just fascinating as to why that resistance drop. Was that particular strains that have come along, are they more aggressive on tomato, which does seem to be the case, and they just the value of the fact that they have the trait of being more aggressive on tomato than the strains that were resistant to ridamil. That's a stronger selection trait. Ability to attack tomatoes. Also looking at a pathogen that tends to exist as a more clonal population. So variation in the population to select for. But it's very interesting when these things happen. There's things we don't expect to happen. Makes sense, kind of an exciting field. A little hard to know what to expect.
So I have two more questions, unless Hillary has some things that have gone privately to her. One question is, when suspecting resistance in a region, should one take one isolate from many fields of a crop, or should one take many isolates from a few fields?
It's also $1 million question, and it comes down to who's, first I know who's going to do any kind of testing that's going to be done on it. There's great limitations as to what can be tested. I would focus on fields that have got that seem to have the worst issues, so chance of picking up a resistant strain. Making sure there are other reasons for control failure. That's something else I talked about on Monday, so that you can rule out other possible causes of resistance. That helps, Jen?
And this is the last one that I have. It's so comment on combination products having lower amounts of AI than standalone products. That is not two full rates, but somewhat less than full rate for each. Thus, the recommendation for combo SDHI products on tree fruits is always use a max rate. Reduced rate would provide inadequate doses of those components. And I think you covered this a little bit on Monday. So I don't have any more comments.
The combination products I have seen have maintained the active ingredient of the product that's most at risk for resistance, but we've seen the reduction has been with the broad spectrum component that's there, such as chlorothalonil. So fungicide like Zing, and the amount of chlorothalonil that's in it is lower than the amount that would be if you were to use Bravo alone. You'd be a higher rate of chlorothalonil and Bravo alone. The thing to realize is that the rates that these products are registered at is a bit of a guess as to what's going to be the best rate. It's based upon efficacy trials that were done by people like myself and other researchers who were testing fungicides before registration. It can be like the situation with the DMIs where we're testing them on that's in the midst of going through selection pressure and shifting. So it might not be the best rate that gets registered. They're also thinking about cost of the product. They're thinking about residues. There's a lot of things that go into selecting the rate that goes on the label. Really, when products registered, you don't necessarily know whether it's going to, what type of resistance, if it's going to be quantitative or qualitative.
All right. Hillary says she doesn't have any private questions. I don't know if you've been able to look at your own chat feed there, Meg, to see if there's anything hiding in there, because I can't see it if they privately. But I don't have
seen anything, but I haven't been looking that closely.
Okay. Well, I think you did a great job. Thank you. That is a lot of material, and I'm sorry about the highlighter, and I'm also sorry about the audio. It did cut out, but I've heard from a few people that said their audio on the phone was perfect, so I'm encouraged to think that the recording is probably just fine. So we will post that on the Moodle, and we will meet again next Monday. Dr. Ray Aloykin will be talking about insecticide resistance, and then have a good weekend, everyone.
Yeah, we again, a few minutes early because we'll have another multiple question poll for folks to attend to. So thanks a lot.